Okay, here we go with part two, and we're not done with the basketball example yet. We're going to go through very quickly a couple of the what ifs. What ifs we change some stuff. So in this situation, if they move closer, what would happen? Well, what would happen to the graph? What would happen to the equation? Well, the graph, if they move closer, this maximum would change. If they move closer, it would go down, right? Maybe that would change to 200 centimeters rather than 280. And so that would squish everything else down, right? This would change from 200, this would be 100, and then both the vertical displacement and the amplitude would change. If they moved closer, quite a few things would change. And in fact, probably the period would change because if they're closer together, the ball would go back and forth quicker. And similarly, if they just passed it faster, assuming they're back at their 280 centimeters apart, if they passed it faster, what would change? Well, it would just complete a cycle faster, that this number would be a smaller number. The period would be lower. This might be 1.5 seconds instead. What happens if our distance was from a point in between? Notice, remember, this distance was from Miss Stone. It went from 0 to a maximum to 0 when Miss Stone had the ball again. But if we actually thought of it as a point in between, there's Mrs. Stone there, Miss Stone, and there's Miss Stone's daughter. And if we're measuring from this point, we have to think of this distance as being a negative distance and this be a positive distance. What would that mean? It would mean the whole graph then, even though if we started with Miss Stone with the ball, would start negative 140 centimeters. And same down here. So what would change in the equation? Well, suddenly we wouldn't have a vertical displacement because half of the numbers would be negative and half the time the ball would be to the right of this distance in between. And so that's one thing to be kind of mindful going forward. What would happen is this would disappear. We wouldn't have a vertical displacement at all. And depending on how we decide to measure these things, we could get a simpler equation, right? This vertical displacement would be 0. The average distance from this point would be 0. What would a phase shift represent? Well, we kind of mentioned this earlier. A phase shift would represent, this graph starting in a different position. Well, we kind of started it here just so it was easiest on us, right? We defined the time equals 0 as at some time when Miss Stone had the ball. But if that wasn't the case, it would be perhaps somewhere in between. Maybe this would be when the ball is halfway in between them. That's when time equals 0 would start. That's when we start our counter. And the phase shift would be a simple change in when we started keeping track. And these sorts of questions sort of really help you demonstrate whether you understand not only the trig functions but the connection to the situation. The next one is a different type. Instead of having to come up with the model of a situation that's given to you, this one is been modeled for you. Here's a situation, there's the equation, now we have to use it. Okay? So I'm going to, or you pause. I don't have to pause the video for you to read. You pause the video and read, and then we'll be back at it. Okay, so now you get the idea, I hope. And I'm going to answer these questions down here. A and B, I'm going to put those both on the graph. Okay, so I'm going to go right from this to the graph. I'm going to actually zoom out so we can see the function still. There we go. I'm going to put them both on the graph. Well, what does all this stuff mean here? Well, we normally see this part on the end. This is the vertical displacement. This is kind of where we like getting started these, is the vertical displacement here is 7.53. And as it turns out in this situation, it's actually the average temperature. And then I have to go up to my maximum. Maximum is going to be up here somewhere. And how far up is that maximum? Well, the max is at the average temperature, 7.3, plus the amplitude. Now, the amplitude is this little business on the front, and I don't know why they're trying to be so accurate with these numbers, but this is about 31.6, which sounds like a pretty warm maximum. And then the minimum is actually going to go to the negatives, and negative temperature. That makes complete sense in Stratford. Where's this place? Does it say what town this is in? No, it doesn't. That's okay. The minimum is the average minus an amplitude, which is, looks like that's around negative 17 point. That's cold. That is cold. 17.4-ish, maybe. You can make fun of my arithmetic if I goof that up. And that gives me the amplitude, the vertical displacement. Now we got to figure out how to actually sketch this. And I see the phase shift is left 2 months. And by the way, this is all in degrees Celsius, so I can state the vertical displacement in degrees Celsius. Left 2 months. So I'm going to change my color and go left 2 months. Right there, -2. It's a sine graph that starts at its average, right? It starts at its average point 2 months before we started counting. Then notice the period. This is one of those application ones. We're not going to have pi's along this, because this is going to be months along here, months. The period is 12, so that means important points every 12 divided by 4 quadrants is every 3 months. And so I can, place the important points on here every 4 months. 3 months. What am I talking about? 3 months. Yeah, 3 months, 3 months, 3 months. And there's 1 season, 2 seasons, 3 seasons, 4 seasons, and then we back to a full cycle. That's a full cycle. And I can see then my sketch, middle, high, middle, low, middle. Dandy. Where Tn represents the mean temperature in the n month, with n equals 1 representing January. So n equals 1 is January, and it's 31 degrees. That looks like, that seems strange. Where is this place? No, it's not. This is not local. This might be in the southern hemisphere somewhere, I suppose, unless I goofed this up. I can see the phase shift back left 2 months, and now let's start answering the questions. This seems strange that in January, month 1, that it would be 31 degrees. This is probably like Sydney, Australia, or something like that, maybe. But let's answer some questions. Well, I'm not going to answer all these questions. Almost all of them you can get from the graph. Using the equation above, determine the mean temperature in the following months. And I'm not going to do all of them, but February, right? If January is n equals 1, February is n equals 2, and then all I would have to do to answer this question is put 2 in there and jam it into a calculator, right? T at 2 equals 24.1, the sine of 2 pi over 12, 2 plus 2, and watch your brackets when you're putting this into your calculator, plus 7.53, jam that into a calculator, and you'll get an answer. Do I have an answer here? No, of course I do not. I'm going to pause the video and clunk that into a calculator. All right, there it is. Bam. Calculator and calculation. Watch your brackets here on 28.4. Notice that we could use the graph to check that. Month 2 would be in here, and that's still a pretty high temperature in February. I wish it was 28.4 degrees Celsius. And notice these other ones are similar, right? I just have to count off the months, and June would be, month whatever. Probably if January is 1, June is 6, and December is 12, and I just jam those into the calculator. What the next challenge is what happens if I want to find the other way? When the first days of the year when the temperature is 10 degrees Celsius. Well, where's 10 degrees Celsius? This is 7. 10 is going to be somewhere in here, right? Here's 10 degrees. So where would it be? Well, notice it says to use the graph. Why couldn't we use the equation? Why not? Well, it's because we don't know how to solve this sort of thing equal to 10 degrees yet. It's, it's too hard. It's steps that still have to be done. And then actually, that's the next chapter of trig, is to solve that very thing. So what we have here is just reading it straight from the graph. It looks like maybe somewhere in late third month. Late in month 3 equals n. That's what n is equal to. Or March, it's 10 degrees. And then you can finish them off. And notice here's some what ifs. How would a function for Stratford be different than this one? What would a period of 18 represent? Period of 18 doesn't make any sense, because a period of 18 would mean that our year is 18 months long, right? It just doesn't make sense. We can't change the period, not like the basketball pass where we just passed faster or slower. How would the function change if the temperature was measured in Fahrenheit? If the temperature was measured in Fahrenheit, probably it would just be moved way up. Maybe the amplitude would change because the minimums and maximums were further behind, further apart rather. This scale would change. The other things wouldn't change. These are good what ifs. I'm not worried about the rest of the details. We still do have an example left, and it's one of my favorites, so we're not going to skip over it. It's the who done it, and I'm going to pick that up in the dreaded part 3.